like 2 cents off, and they just let me go, and I'm like, you're serious?
No, it's charging.
What are you really? It's 2 cents. Are you joking?
They wouldn't?
Yeah.
I thought you said they did it. I was like,
No, they didn't. I think it was like a McDonald's or something. I have like the permit. Maybe on the screen.
How come the camera doesn't work anymore?
Off 25 cents. So the person behind me paid for it. The whole thing.
Well, half of it's
Oh, I think was it there? No, look at the bag.
No, that's where I wanted to do my eyebrows. And I was like, actually, like a teapot, and I thought they were only 75 cents. I brought
This
a
is
dollar.
like Starbucks.
Yeah. And so I only brought a dollar, and they're like, oh, it's 125. And then so I was like, okay, I need it. I'm sorry, I can't have it. But then they're like, oh, don't worry, I'll take care of it. And then I keep the dollar.
Yeah, I think that's happened to me once too. Like the upper did. I'm like, no.
What did you say?
It was old.
What'd you say?
It was a woman in her 20s.
Oh.
She was just being nice.
Yeah, well, mine was a guy, but some people are just nice.
In that case, that's fine. Because that's happened to me for men. It's kind of creepy.
That's a little creepy.
Yeah. Like, don't worry a little bit. I'll take it for now.
Or also, excuse me.
No.
Well, if it was for me, I would be like, okay, we'll take it 5.
I think that's my break. $10 order.
I'll be like, in that case.
In that case, let's double the order.
Options for Oscar?
Yeah, of course. Awesome.
Oh, you didn't tell me that?
They actually make it. Everything they do at the deli, they actually make.
Okay, we're gonna get started here. Oh, it's good.
It's fine.
So, we should have all done 1 through 6 in class. I think in period 3 we did 7 also.
Yeah.
8. And 8.
And we did 8, okay. But we didn't do them in period 1, so we'll just start from here. So number 7 is about a blind experiment, or what a double-blind experiment is. So I thought I'd take a minute to just remind you what a blind experiment is. A blind experiment is when the subject does not know the treatment they are getting. So
So placebos are in order.
this is when placebos are necessary. If you're going to do a blind experiment, then the placebo needs to be as similar to the treatment as possible. So if the treatment is a little white pill, then the placebo would also be a little white pill. And if the treatment involves a shot in the arm, then the placebo would also be a shot in the arm. Okay. And remember, the reason why you want to do this, or why you want to blind the subject, is because sometimes just knowing you're receiving a treatment is going to affect what you perceive as happening to your body, or what's happening. So those psychosomatic effects are known as a placebo effect. If you give someone a pill that looks like if someone thinks that they're getting treatment, then they're probably going to respond better psychologically. Now, so that's a blind experiment. Hey, how's it going? Oh, I had my...
Kevin?
Kevin?
Sorry, I'm talking to myself.
Oh, it's not. A double-blind experiment happens if first of all, it's blind, so the subject doesn't know if they're getting a placebo, if they're getting a treatment, or if they're getting treatment 1 or treatment 2. But a double-blind means that the person collecting the data, I'm calling him the data collector here, doesn't know if the research subject has a placebo or not. Because sometimes a researcher would be known to, how do I say this, influence the data if they know that the subject is actually getting treatment. So you don't want you want to keep the researchers or the data collectors, hello? You want to keep the data collectors as, unbiased as possible. And you want to keep the subject as unbiased as possible. So when these are important concerns, and they're not always important concerns, but when they are important concerns, you want to utilize a double-blind experiment. Okay? So you want to use a double-blind experiment because, yeah, all of these are true. There's a natural tendency for a subject to want to please a researcher because it'll help control for the placebo effect, because evaluators of the response can influence the outcomes if they know the subject are in a treatment group, and subjects in a study might react differently if they knew they were receiving an active treatment or a placebo. So they're all true.
So the double blind, the researchers know, but the data collectors don't.
Yeah. They're like some guy who's controlling the experiment at the very top level. He's the only one who knows which person's getting treatment, which person's getting placebo. Question 8 was a car question. And in this car question, you're interested in determining which 2 brands of tires will last longer under different conditions. We have 50 Toyota Camrys and 50 Honda Accords. Camrys get brand G, the Accords get brand F. Each car is driven 20,000 miles and the tread wear is measured for each tire. The average tread wear for the 2 brands is then compared. Now that sounds like a great experiment, except for everybody who's receiving brand G tires is driving a Camry. Everyone who's getting brand F tires is driving an Accord. And I would imagine there's a difference in the way that the 2 cars wear on their tires. And different weights, yeah, exactly. So because the 2 cars have different tire tread wear, that's an important variable that will affect the outcome. So it'll confound the outcome. So the brand of the car is the type of the car is a confounding variable. You need to do something to minimize the bias due to that confounding variable. Most likely you would want to either block by car, so take the Accords in one block and the Camrys in the other block, assign half of the Accords to tire F, half the Accords to tire G, and then break up the Camrys. Half of the Camrys get brand F, half the Camrys get brand G. Or if you don't feel like doing it that way, you could probably do a matched pair design somehow. Or if you don't like doing that way, I suppose you could do a completely randomized design where some of the Accords will go to group 1 and some of the Camrys will go to group 2. Probably some kind of a matched pair or a block design would be best here.
Wait, what's confounding variable again?
Confounding variable is anything that affects the response.
Okay. In like a way that is wrong.
As long as it affects the response, it's confounding.
Okay, so even if you correct the experiment when it'd still be confounding, right?
It would still be a confounding variable, yeah. You have no control over that, that variable. You can try to minimize the effects of the variability due to that, in this case, the car make and model, but you can't completely eliminate that source of variability. Okay? Okay, and question 9. Psychiatrist is studying the effects of regular exercise on stress reduction. Identifies 40 people who exercise regularly and 40 who do not. Each of the 80 people are given a questionnaire designed to determine their stress levels. None of the 80 people who participate in the study knew that they were a part of a study. Interesting. Which of the following statements are true? Well, first of all, this is not an experiment. You are not telling the subjects to do anything other than complete your little survey. Okay. So because of that, this is not an experiment. So anything that has to do with an experiment is false. The only one that is correct is the observational study. So this is an observational study.
So just because it's not an experiment, it means it's observational even though you're getting involved?
Yeah. As long as you don't tell them what to do. I mean, if you automatically assign them into groups and treatment for those groups, then that's an experiment.
So it's only an experiment if you're giving a treatment, otherwise it's an observation no matter what.
Yes. It's a very good way of putting it. Okay. And question 10. This is the last one that I pre-wrote up for you. Question 10 is, an electronics firm wants to survey its employees to determine their attitudes toward employee compensation. They obtain a sample for the survey by randomly selecting the first 20 names in an alphabetical list, and then, or one of the first 20 names, and then select every 20th name onwards. Okay. From what we've known or we've done, that's a systematic sample. There is some kind of a mechanism to go ahead and get the next person, and it's not random after the first person. So that's a systematic random sample. Remember, it's a systematic random sample is not a simple random sample. It's impossible, for example, to get 2 people from the first 20 names. Hello. Impossible to get 2 people from the first 20 names on the list in the same sample. So no. Okay. And that brings us to 11. 11. Let's see. Results of an experiment are said to be biased if definition of bias means it systematically favors one outcome. Okay, subjects are not randomly assigned to a treatment group or a control group. Well, that would bias your survey. Some outcomes are systematically favored over others. That's kind of exactly what I said. C, there's no control group. Not having a control group won't bias your survey, but it'll definitely limit your ability to generalize from your results. The double-blind procedure was not used. Not every experiment needs to be double-blind. And E, the sample size was too small to control for sampling variability. Well, that's going to make your analysis difficult, more difficult, but it's not going to bias necessarily. So the only one that works here is, was that C or B? B. Ah. B. BB. Okay, 12. A study shows that a person who ate 2 carrots a day had significantly better eyesight than those who eat less than 1 carrot a week. Which of the following statements are true? This study provides evidence that eating carrots contributes to better eyesight. That's tempting, right? Okay, general health consciousness of the people who eat carrots could be a confounding variable. Yeah, that's true also. If you're eating multiple carrots a day, then you're probably going to be taking better care of your body. So eating more carrots might signal a person who, quote, takes care of themselves. And lastly, this is an observational study, not an experiment. Yeah, we didn't impose any treatments, right? So let's see. What was A? A was provides evidence. Yes, this provides evidence. Evidence, but doesn't prove. Okay. B is also yes. And C, I think that's the yes also, right? This is an observational study, yeah. No treatment was imposed. So I think all of the above.
One wasn't right.
One wasn't right? The study provides evidence that eating.
No, that's good.
Yeah.
Couldn't
Isn't
the
one
person's
wrong?
overall health be confounding that as well?
Yeah, you're right. There's a confounding variable thing going on here, but I don't know.
Obviously, people are eating carrots from sitting concentrating.
I think the idea here, this is actually very weak evidence.
That's what I'm saying.
Yeah, it's not good.
Yeah.
Because it might, maybe, is it evidence that suggests? Maybe, is that?
Right. Right. Maybe what we're saying here is that, or the thinking here is, the way this is phrased might imply a cause and effect relationship. Let's read this carefully. The study provides evidence that eating carrots contributes to better eyesight. Does that sound like a cause and effect relationship? It kind of does, right? Yeah. So, well, let's change that from yes to well. Very weak evidence. It shows a relationship, but not a cause and effect. Okay.
I don't understand what's the difference then?
Relationship just means that the two variables move together at the same time. Or, if this changes, then this will also change. That doesn't, as opposed to if this changes, then this necessarily has to change. It just says both relationships or both variables change together. Yeah.
So, but if, let's say, you're conducting like an experiment, you say you give these people carrots and these other people they don't eat carrots, and they get the same outcome, would that make one correct?
In an experiment, then yeah, that would be stronger evidence. I think that kind of thing you'd have problems with experimental design though. How do you measure? You'd have to show that the eyesight got better or didn't get worse. What would you be measuring? But you're thinking on the right track. Okay. So is that then, so just 2 and 3?
Yeah.
That number 1 is a little bit tricky. Okay, and 13. Okay, you're testing a medication for the relief of depression. You're given a new medication to subjects suffering from depression to see if their symptoms lessen after a month. You have 8 subjects available. Half are to be given the new medication, the other half are to be given a placebo. Sorry, other half. The names of the subjects are below. We're going to use a random digit table. So let's see. We want to pick 4 people, right? So the first 4 non-repeats, ID numbers, will be part of the treatment group. The remainder, we're going to put them in the control group. Okay. So the ID numbers that we get are 8. Next one is 1, Next one is 5. And the next one is 0. Oops. 0 doesn't exist, right? So we're gonna strike that out, right? Or strike through, there we go. So not 0. What's after 0? 7. Is there someone with a 7? Yes, there is.
Yeah.
Did we choose 7 already? No. Okay, so this is our treatment group. So treatment group. Yeah.
Oh, the question doesn't say the first 4 like numeric number. It just says first 4 stuff.
Yeah.
Couldn't that just be the top row of names will be the one selected and the bottom will be?
But that's not a random, because the names are alphabetized, it's not really a random selection.
No.
Yeah. So who's 8? Tang? It's 8. Who was number 1? Blum what?
Blumenthal.
What a weird name. It's number 1.
House.
House?
Yeah.
Like House MD?
And Pavlikova.
Pavlakova? Pavlikova?
Yeah.
That sounds fake. No, Tang's not fake.
House is bossy.
House practices medicine. Okay, so what do we got? We got Blumenthal, House, Pavlikova, and Tang, which is letter B. That's great. Okay, 14.
Which one did you get their placebo?
Oh.
So wouldn't it be the one that's below the list?
So the placebo group.
So it'd be D.
Placebo group is everybody else, right?
Yeah.
Which is 2. Who's number 2? Costello. Who's number 3? Who's number 4? Fan. Long. What number is long? 6?
Yeah.
So yeah, did that, that's choice D. Choice D. Okay, 14. Sickle cell disease is a painful disorder of red blood cells that we said mostly affects blacks in the U.S. To investigate whether the drug hydroxyurea can reduce pain associated with sickle cell disease, a study of National Institute of Health gave the drug to 150 sickle cell sufferers and the placebo to the other 150. The researchers then counted the number of incidents of pain reported by each subject. What is the response? What are we counting? Response means what are we counting? What are we counting? We're counting the number of instances of pain, right? So that is my response, letter B. So remember, no matter what your experiment is trying to show, your response is always what is being counted or measured. I have a feeling that's going to be really good advice for you. No matter what your experiment is trying to prove. Okay. In this case, our experiment was trying to prove whether a drug lessened pain associated with sickle cell disease. So even with all of that, very lofty goals, even with all of that, that's not the response variable. Response variable is always very simple. What are you counting or measuring? If you're measuring the number of instances of pain, then the number of instances of pain is your response variable. Okay? And that's all of the free response. That's all the multiple choices.
You should probably edit that out.
Meh.
Take two.
I think the people at home deserve a laugh too.
I just usually
Your response.
Okay.
Guess what's not opened? No. Free response questions. A petition of 500 signatures is being submitted to the high school. No, I didn't say high school. The school principal. I feel like I've told that story already. Principal? Okay, good. Principal. The principal would like to check which portion of underregistered students and fake names. Oh, that sounds like a pretty good. Just look for all the Haywood.
Oh my god, I just said that.
Yeah.
Yeah, I was like, just look for that name.
Isn't Vaughn?
All the Haywoods and the. Think of another one.
What's Seymour Bus?
Seymours. All the Seymours. Yeah. There's got to be more. Anyone else fake names?
I don't know.
Oh, all the Ben Dovers. Yeah.
I've seen someone's computer multiple times.
Okay. Okay. There's not enough time to check the entire list, so we want to create a sample of 30. Any ideas?
Well, they're already numbered, so I don't just use the random digit.
Okay. So I'm hearing a lot of people say assign numbers.
Well, they're already signed.
Are they?
Well, aren't they? Because they're.
There's nothing here that says assign.
I guess it's on something.
Okay, so I think the response that I would probably favor from you would be to give each signature a random digit using a calculator from 000. So that gets me to 1,000, right? We want to get to 3,000, so one more to 9999. Okay, so that ensures me that I'm not going to get a lot of repeats. Actually, we might just do one more, just to really ensure. One more order, just to really make sure that there are no repeats.
Your answer says 3 digit.
3-digit? Oh, I think I'm deviating from that answer choice. Sarah, let me finish this before I get to you, okay? Using a calculator. Okay. The students or signatures that receive repeated ID numbers will be reassigned an ID number until they have a unique ID number. Okay. The lowest 40 ID numbers, 30, thank you. 30 ID numbers will comprise the sample. Okay? And I think that's different from what it says on yours. Yeah, one example, use a random digit table or graphic calculator to give each student a unique 3-digit ID. Oh no, this is the same thing. The 3 smallest numbers will be included in the sample.
The only thing different is that it's three digit.
Okay. Yeah, the difference is instead of a 3-digit, I'm going 5 digits. That's going to ensure, or not going to ensure, but that's going to minimize the number of repeats at each ID numbers. And also, I'm writing out what to do in case of a repeat, which is also important.
Don't you just do it again if you get a repeat?
Yeah. Okay. Sarah, what were you asking?
That's okay.
Got it?
Yeah.
So if it did say it was already numbered though, we could just say to go.
Yeah. If they're already numbered for you, then just use a random digit table to pick. Question 2? You know what, though? I'm sorry. Let's go back to this one. It seems to be that if you're going to give a random ID number to 500 signatures,
Like you're gonna.
That's all.
That's what I don't want.
you might as well have just,
Yeah.
checked them.
You could just go on the PA and announce the names and see which kids laugh.
Well, that's so like couldn't you just assume that went through typing?
Well, there could be people where they put down a fake name, and that's not necessarily a goofy name. Yeah.
Okay, point taken.
No, but Khan is a very common last name.
Yeah.
Yeah. Sarah?
So if you did a different way and explained yourself, would you still give us credit?
As long as it's actually an SRS.
So if we did like the random 30 numbers, like 1 through 500, and you just pick random 30 numbers, do the random on your calculator, then that would be fine.
Then that would be fine too. But remember, you have to talk about what to do if you get a repeat.
Okay.
And yeah, how to start, how to stop. Okay.
Why can't you just say since you know there's 500, can't you just pick 30 random numbers and just count down? Or
What are you saying?
since you know there's 500, can't you just like search numbers one pick 30 random numbers? From
Well,
one-
what kind of IDs do the students have?
Can't you just assume it's 1 through 500? Like,
Can't assume anything. You know? Okay, let's go to question 2. The size of the tip that a waiter receives is determined in part by the server's behavior. Yeah, that's pretty true. In an experiment, a waiter would like to flip a coin to determine whether to stand or squat by the table. What kind of squat are we talking about here? Squats. Are we talking about the Asian squat? Is it? No? The Asian squat. The waiter will record the amount of the bill and the tip and whether he stood or he squatted. Okay. Describe the treatment and the response variables. Okay, so what is the treatment? Stance, squat, or stand.
And then how much do we consist?
That's
Which letter? What is this? The response.
Yeah.
that's a response.
What is a response?
How much they make?
How much of the tip you're getting?
Couldn't it
Yeah.
be like percentage since different
This is a really
bills might be
difficult
different?
one to do because people don't tip.
Hmm.
Oh,
I tip.
You don't tip?
half the time.
Everybody tips.
The tip received.
Put it on.
Okay. Now that's what you're really recording, right? The tip received. But I don't think that, if you're going to actually do some statistics, some number crunching here, the amount of tip is probably not as important as the percentage of the tip, or the percentage of the bill, right? So maybe we should say the tip received as a percentage of the total bill.
Yeah, because some people just tip by percentage.
Okay. So you want to see, when you squat, will you receive a smaller average tip percentage? I don't know. There we go. Letter B. Describe possible extraneous factors and how they could be controlled. So let's just go with 2. Are there any extraneous factors that you want to talk about? Yeah.
Maybe the people the waiter is serving are just assholes.
So the personality of the.
Well, you know what? But that kind of variability is not the kind of variability that we could control for.
What the size of how about like
Okay.
Size of the party.
Yeah.
Gender and age of the waiter.
Gender and age of the waiter. Okay. But I think we're only doing this for one waiter. We don't have a team of waiters. So there's no what I'm saying is there's no variability in the age and gender of the waiter because we're only talking about one waiter.
how about the size of the meal served?
Attitude? Explain.
The server could joke around, or
Okay.
he or she could
Be completely serious.
completely serious. Like it's the most important thing.
Toward the customers could vary. Okay, so that's the source of variability. How would you control that?
They have to have the same kind of attitude with the rest of them.
Give this sign, decide which customers, every other customer, you be funny, every other customer.
Well,
No, they have to have the same attitude.
I think you want to control it, so yeah.
Hire an actor to do the job.
You should just tell them before that they have to have the same attitude
Yeah. So
before the experiment starts.
the server must maintain the same attitude to all customers. Okay. Is there another one that we want to talk about?
Oh, as you talked about
Remember, there's only one waiter doing this, so there's no variability
it's your answer key.
in the server.
It's your answer key.
It's my answer key?
It's your answer key.
Ah, bummer.
What about the way they're dressed?
There's only one waiter, so there's no variability in the way that the waiter dresses.
Well, like, it could be a girl in her bikini now.
There's only one waiter.
Yeah, but it could be like hourly, you change your outfit once the customer's leaves.
Why would you do that?
It could be more of an exposing outfit or more conservative.
See, that's. I mean, just kind of reading the way that this experiment is being conducted, though.
Well,
There is only one waiter doing this.
well, how about like the time it takes for them to get their food? Because that could vary based on how
Okay.
busy it is in the shop.
Because that's something that's not in the server's control. Okay, so the speed, I like that one. The speed with which the customer's food
The amount of money the customer has.
You can't control it
food arrives at the table could affect the tip, right?
But doesn't that depend on the cooks?
That's exactly right. That's how come it's a confounding variable.
But the waiters could be walking
We're talking about one waiter. Okay. Could affect the tip. How could we control for that?
The survey can be conducted during earlier hours during the week. It's not really too busy.
Well, you could,
Um,
maybe they could do the survey and the experiment at a certain time where how busy the restaurant is, the customer
Okay.
is saying.
So we need to, I think it's the same thing that Matt was saying. We need to conduct a survey or conduct the experiment during. How do I say this? Uniform busyness. Difficult question here. There's a lot of things that could happen here. But remember the things you have to, when you're doing this, the variability has to be something which is, something that you can control for. Variability in the customer's attitude here, that's what you're testing. That's not a source of that's not a confounding variable. That is what you're looking for. You're assuming that is going to be different. So you got to find things that will affect your response that you're controlling for. Okay? C. Discuss whether blocking would be necessary. Would you need to block? Party size?
Well, I think possible.
Okay, so what we're saying is that party size will affect the tip?
Oh yeah, because you have to have 6 or more
Quality
people.
of food.
No, don't bring quality of food in here yet. We can definitely block this, right?
Some restaurants make parties of a certain amount of people contribute greater than.
Yeah.
You said price of food.
We could block by party size. Okay. What else could we block by? Gender. Gender of the customer, right?
You say how much the customer spends?
How about the age of the customer?
A source of variability.
Yeah.
So block by gender. And maybe one more. Age
The
of
amount of the bill?
Age of
the amount of the bill.
Like from a certain range of.
Yeah, like-
she means, like from like say from like.
10 to 20, whatever.
Wait, you wouldn't know what they're ordering until after.
Yeah, but if you
Like,
block it
are we
out.
Usually with a
are
big
we-
group,
are we
you
trying to
know
go
what they're
for-
ordering.
When the tip increase as the check increases.
But
And
how are you
that's
gonna know
part
on the
of
spot?
basically what you're saying is that your response variable is the source of variability. That's not a that's of course it's a source of variability. That's what we're looking for. Age
Yeah,
of
age of the customer. It's like younger
age
people tend to might tend to
customer
might tend to feel sweet plus because they don't have money.
variability. So block by age. Okay. Remember, we're looking for unavoidable sources of variability. We're not looking at the treatment, we're not looking at the response, we're looking at something that's not part of the treatment, not part of the response. D, identify possible confounding variables. Well, we've gone over this like a bunch of times, right? So. That's D, right? So C. B, and C. For sources for confounding variables. Those are all confounding variables, which is why we're blocking to begin with.
So the confounding variable is just things that can affect it in general and like. the other
Things that can
variables-
affect the response variable.
Yeah. And then we're talking about the.
Or things that are not the treatment that could affect the response variable. Okay, let's write that down. A confounding variable is anything that is, quote, bold, not the treatment and affects the response. Variable. Three. Pismo Beach, California holds an annual clam chowder contest. Judges rate clam chowder from local restaurants, and one year Denny's clam chowder was declared the winner. Seems highly unlikely, but
It was blind.
was it blind?
Couldn't taste.
Part A. The judges claim clam chowders participated in blind testing. What does this mean?
What restaurant?
Right. The tasters did not know where the clam chowder came from. I mean, it came from clams and cream and okay. That was A, right? Okay. And how about B? What's B asking? Do you think Jenny would have won? That's kind of a
Biased question.
no.
Isn't that a
Very
biased-
strong reaction here. Why no?
Isn't that a biased question?
It's meant for like a,
Well, it depends
it's
who.
known for like a breakfast.
Doesn't mean it has good ones.
Who
Who else was in it?
Whether they like Denny's.
Yeah, it's like a bias.
That's a biased question.
I like that.
Whether
No.
they like,
Josh, can you say that one more time?
you could say like, it depends on whether the tasters, whether they like one clam chowder over the
But
other.
it says it wouldn't.
And they're
You're
biased.
saying
They
the
would,
question is
they
biased.
would be biased towards
Yeah.
the one they really like.
But they could have still won. I don't
Food from Denny's, so does that have to be
Just
very
because it's biased doesn't mean it.
Oh, I think we had it there for a minute. Now we lost it. What were we talking?
biased towards the restaurant?
But they could be biased in favor
There
The
is.
physics,
and against.
the taste tester,
So they could have never been to to one of the restaurants.
No, I'm not following us anymore. I'm not
there could
following.
be a bias towards which clam chowder they prefer, from which restaurant.
I don't know why.
Okay, wait, hold on. Let's concentrate on the question here. Do we think Denny's would have won?
No.
Why?
No. Why not?
Because don't expect Denny's to have very good food.
Well, what if they like
Okay,
it?
so no, there is the opinion that Denny's does not serve quality food.
They could be
This could, or this opinion would bias a survey that is not blind. Okay. If you know where it's coming from, then you're not necessarily rating the clam chowder, you're kind of rating the restaurant.
But what if they like Denny's? Why does it have to be against it? Why couldn't it be in favor?
Could be in favor of it too.
So you could,
Yeah.
I'm not saying it's like biased. I'm just saying it doesn't have to be no.
Yeah.
so you could make an argument pro pro Denny's, you could say like yes.
Absolutely. Oh, well, it's just, the answer is still no. They probably wouldn't have. Probably wouldn't. Well, no, I guess you
What
could
if,
say
what
yes.
if the person thinks that
But-
Denny's has great food and really applaud it? I'm not saying. Just
You know,
it is biased.
Either way, you have to defend it based on. We think that people are. We think that Denny's has good food. Therefore, we think that they would probably win because people enjoy Denny's foods, or the other way around. We think the popular opinion is Denny's has bad food, so they wouldn't win.
Couldn't you base it off your own opinion and support saying that they could have won, say somebody really likes Denny's?
Yeah, you know, the point here is that you're gonna back up your argument with your response with an argument.
Okay.
Yeah, Alex.
So the blind test would serve like a more accurate survey than a non-blind test.
In any things that require something like an opinion, you're gonna want a blind. If there's definitely some kind of a pre-existing opinion, then a blind would be a good idea. Okay, okay, we should write that. The bias comes from a preformed opinion. In this case, a preformed opinion about Denny's.
So basically, as long as you mention bias and back up our answer, it's technically correct for this one.
Yes, as long as you make an argument in support of what you're saying, your argument has no logical flaws. You know, all of these things have to happen. 4. Researchers at Penn would like to see if a nasal spray is beneficial in relieving the symptoms of premenstrual syndrome, PMS. The experimenters would like to experiment that tests the spray with a control group, placebo spray. Since the effectiveness of the spray may vary by weight of the subject, the experimenters plan on using a match pair similar group design. There are 40 subjects available. Sketch a diagram for this. Okay. Let's see. Let's sketch this diagram. What's the first thing we need to do? The first thing that we need to do, pair the subjects. Pair the subjects by similar weight. Okay, so after we have paired our subjects, what do we need to do? We need to randomly allocate the pair, right? What words do we use here? Random allocation for each pair. So some of the pairs will go to treatment group 1. Some of the one half of the pair will go to treatment group 2. Okay. So treatment group 1 will have how many ladies? Group 1. One 20 subjects. Group 2 will also have 20 subjects, right? Wow. Group 2 is also 20 subjects. Okay, and group 1. Do they get the placebo or the treatment? Treatment. Good. Treatment run. What's the name of the medication?
Nasal spray.
Well, no, they're both going to be nasal sprays.
You could do real and placebo.
Well, just placebo with the nasal spray.
Well, they're both nasal sprays.
Yeah, but what's a placebo?
Real spray. Real nasal spray and placebo spray.
Real nasal spray. That's real nasal spray. That's hilarious. That's some good Benadryl. Treatment 2 is going to be
So,
2 is going to be a placebo spray. Yeah, probably just water. Maybe flavored water. Scented water. Rose water. Rose water nasal spray.
because you can taste someone using a nasal spray salad.
Okay, and lastly, we're going to compare PMS symptoms. Okay, and that's it. Let's draw some arrows here.
The important part.
Okay, there we go. That's a good match pair, similar groups. It's very exciting. Question 5. I wonder what that was. Disgusted, A-Rod leaves the hearing saying he's done with the farce. Farce.
Farce is a great word.
Okay, 5.
So you wrote this one?
Yeah. Can we make a better Powerpuff Girl?
I stayed for this special.
Professor Utonium decides to design an experiment with 2 levels of sugar, spice, and everything nice. SSE1 and SSE2. And 2 levels of chemical X, X1 and X2. To see if he can improve upon Blossom, Bubbles, and Buttercup. Professor Utonium would like a completely randomized design to test the girl's superpowers. There are 50 subjects available. All right. Let's do this. Okay, so firstly, we want a completely randomized design, so we're going to start off by random allocation, right? Random allocation. So we're going to have, let's see, there are 2 sugar, spice, and everything nice levels, and 2 different, X1 and X2. So that sounds like 4 different treatments. So we'll need 4 groups.
Can you make it?
There's going to be group 1, group 2, group 3, and group 4.
You can't make it richer.
Now we can't go 50 evenly into 4, so
13, 13.
yeah, 13, 13, 12, and 12. That's the most even we can do here. It doesn't really matter which of the groups get 13 and which of the groups get 12. You're taking an average of the responses anyways. Okay, group 1 is going to receive treatment 1, which is going to be SSE1 and X1. It doesn't have to be that one in particular, but it does need to be some combination of SSE and X. Treatment group 2 is going to be SSE1 and X2.
Thanks, Mr. Fryer.
Yeah, have a great day. Is it dark out there yet?
Probably.
Yeah. It's getting
So, treatment 3 is going to be SSE2 and X1. Treatment group 4 is going to be SSE2 and X2. Mm-hmm.
Would we wrong if you compared powers twice, group 1 and 2?
Yes, you would. You would. You only compare it once at the very end. Okay. So compare that whoop ass. Compare superpowers.
Yeah.
That's it. Yay. How are we doing time-wise?
It's like 135.
I didn't mean that time. I meant this time. Oh, it's only been 1 hour. Okay, I think we can keep going. Maybe we should just have some shenanigans. What kind of shenanigans could we do on the computer?
Watch that soccer.
Yeah, takraw.
Yes.
Just watch the
What cannot be
YouTube.
Did we like play some random game last year?
Takraw.
We've done like a random stuff. We did a lot of stuff on them last year.
This thing with her brother used to on it, and then
I don't know, I never watched them afterwards. I don't know how they turn it out. What? We did really random stuff on the video.
Ooh, 2013.
what are we looking at?
You know what? YouTube's blocked, that's why.
Don't you have a password?
What will you tell me that couldn't be open?
And then do you ride? Does your mom
Malaysia and Thailand.
กลับมาที่ห้างสรรพสินค้าแฟชั่นไอแลนด์นะครับตะกร้ออีกครับสมัยแล้ว6 ปีแล้วครับอิสกันดาที่เป็น
Just watch a little bit of this.
อดีตนักตะกร้อระดับตำนานคนหนึ่ง
His
ข
name
อง
is
มาเลเซียครับ
Iskandar.
อิสกันดาอาชัดก็ขับเคี่ยวกับนักตะกร้อของไทยเรามาขาดทุนครับในเกม
I think that's the same Thai team.
พยายามจะช่วยกันแต่ว่ากลายเป็น5-9คะแนนชัยดันเสิร์ฟมาพลชัยเปิดเยี่ยมมากพัทรพงศ์ยกสูงมาให้พลชัยขึ้นตู้ผ่านยกของมาชลินไปได้ครับของชอบเยอะครับยกลูกลอยสูงให้มีเวลาได้ลอยตัวไปเอาตัวสอดใต้ลูกแล้วเหยียบมองผู้ต่อสู้สักนิดหนึ่งดูภาพช้าใหม่พัทรพงศ์ ตรงนี้ครับรุ่นพี่ชอบแบบไหนนะซึ่งไปเกี่ยวกับหนีบล็อกของมาซารินไม่แรงไม่ได้ใส่น้ำหนักแรงมากเน้นทิศทางแนวเมื่อสักครู่ของคนไทย
Are there any other
นำ10-5แล้วเสริมยัดใส่ตัวของซาซินเข้ามาโนทรินขึ้นบล็อกมาขึ้นขวามาแล้วก็ผ่านบล็อกของคนใจเขาแก้วครับ
to turn in?
ต่อ10
I didn't actually collect it, but we did 1 through 4.
Okay, so they're
ก็
both
เป็นนักตะกร้อที่อารมณ์ดีนะครับทั้งในสนามและนอกสนามนะครับ
tomorrow you're serving.
นอชรบินเล่นอยู่กับสโมสรพิชนัสนะครับในมาเลเซีย10-6ศิริวัฒน์เสิร์ฟมาแต่จำจุดเดิมไปที่นอชรบินแต่ไม่ได้ครับเดี๋ยวคงต้องปรับฮะเสิร์ฟติดมา2 ผลแล้วครับมุมนั้นยังเอาชนะไม่ได้ของศิริวัฒน์สาขากล้าเลยเข้ากล้าเลยเสียงอาจารย์กมลบอกต้องกล้าเล่นพัทรพงษ์โยนเสิร์ฟมานาชรินเปิดพอได้ฮะชาเชียร์คามายกให้ข้างครับเตะใส่ตัวของพัทรพงษ์จะเปิดตรงนี้ไม่ขึ้นครับต้องชมว่านชรินเองเขาก็เตะได้แรงครับจังหวะขึ้นเอาไปเอาตัวสอดใต้ลูกนะครับเข้าจังหวะได้ดีแล้วก็ดูครับชาเชียร์คามาเองพยายามยกหนีตัวบล็อกของไทยคือพอใจเขาแก้ว
Cheers.
ไม่แล้วเขาขึ้นเตะลูกคานตะข่ายแบบนี้ก็ยัง
Alright, last
ถือว่า
rally.
เตะได้เยี่ยมครับไม่ใช่เตะแบบแก้ไขประคองให้แค่ข้ามนะครับแต่เตะแบบฝังเพื่อเอาแต้มฮะทำได้ดีครับนชรินทร์กลับมาเป็นมาเลเซียจะได้เสิร์ฟใน3 คะแนนต่อจากนี้ครับ8-10ไซดานเสิร์ฟมาพรชัยเปิดเยี่ยมพัทรพงษ์ยกให้เร็วโอ้ติดบล็อกแต่ว่าออกครับติดบล็อกของนชรินทร์ก็จริงแต่ออกฮะพยายามกระตุกยกลูกไม่สูงมากแล้วนะครับพัทรพงษ์ยุพดีแต่นชรินทร์เองยังอาจ
All right, enough of that. Okay, let's see if we can't do something about these last 2 problems. Manufacturer Boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. The company recruits 100 volunteers from Seattle, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of 6 months, the boots will be returned to the company and evaluated for water damage. Describe an experiment that uses these 100 volunteers. Include a sentence on how it would be implemented. Okay. So what kind of experiment do we want here? So match pair.
Yeah, right?
Okay. So how would we match pair? Match pair design.
And then one group would have treated
Well, how would we? What are we matching? Who are we matching? Who with who?
gender. Who was specified gender?
Would gender really matter?
I don't think gender.
I don't think gender is a source of variability here.
Maybe.
It depends. I would say it depends on the landscape. No, wait.
It says
They're all going to be in Seattle.
urban
What would weight be? Something like.
profession where they'd be going.
You know what makes sense professional?
Construction workers versus
Maybe like fishing boots for that.
Maybe like where they live, because it might snow.
Where they live, yeah. What?
Like, where it could depend on the weather, because like maybe they test it out by going through a lake and then even head and then it.
Let me give you the biggest source of variability here is going to be each individual person, right? The biggest source of variability will come from the subjects themselves, right? So we're gonna have to find a way to match each person to themselves. This implies an own control match pair.
Oh, so
Match pair. Own control. Design. Okay. So remember we said 3 months?
it's a
No, it says 6 months, right?
yes.
So
3 and
how many subjects do we have?
100.
300?
Wait, one.
100.
The 100 subjects will be randomly split, randomly allocated, will be randomly assigned to one of two groups. Okay. Group 1 will wear the, let's see. Well, the rain could differ from the first 3 months and the last 3 months, right?
Yeah.
So it wouldn't be fair to give, let's say, the new boots in the first 3 months and then the old boots in the second 3 months, because different seasons. So what we're going to do here to kind of combat that, or to try to minimize those effects, is the group 1 will wear the
The current boots for
will wear the new formula, the new boots. We'll wear a new boot on the left foot
That works.
and an old boot on the right foot.
what the volunteer doesn't have.
Okay.
Is missing.
Is there going to be a source of variability between the left foot and the right foot?
Maybe.
Yes? No?
Final line, it's that's the way they walk.
Sometimes your right foot will get wet more than your left foot?
Maybe.
I don't know. You tell me.
I think so, yeah. Well,
You think so?
there's the-
Okay.
Yeah, that's true.
For 3 months.
6 months. Oh, wait, choose.
Okay. After 3 months, the subjects in group 1 will wear a old boot on the left foot and a new boot on the right foot. Okay? In thinking about this, do we even need the two groups?
No.
Every person's doing the same
Well-
thing, right?
Unless you want to have the right foot, left foot first.
Yeah.
Also could depend on
Because,
the weather.
Okay.
yeah.
Could also depend on what the person does during the
Yeah. Well, that's how come we're doing where every person is controlling with themselves, because the biggest source of variability is the subjects themselves. So group 2 will do a similar 3-month boot rotation, but we'll start with the old boot on the left, right? And the new boot, right foot. After the 6 months are up, the water damage on each boot will be analyzed Okay?
But why 2-3 month rotations when the random outcomes change?
Why? One more time?
If there's 2-3 month rotations,
Mm-hmm.
doesn't that affect the amount of rain, or the rain damage to the boot? There's gonna be less rain in some zones.
Right. So that's the idea here is,
Just trying to mess them up as much as possible.
we'll try to randomize that as much as possible.
Okay.
Okay. Remember, own control is used since the biggest source of variation comes from the subjects. Okay. Since the season and rainfall changes, it was necessary to, I don't know, change.
Both need to be tested at once.
Hmm?
Both need to be tested at once.
Yeah. Let's see, what were we saying about the seasons and the rainfall?
Summer and fall.
Why did we have to take that into account then? What did that change?
Well, some,
Because if the water damage would be different if there's less rain.
Will there be different activity levels depending on the season?
Yeah, but that's going to be that variability is going to be minimized by the own control, by the match pair own control. So
Say more people spend more time at home during winter seasons.
yes, but again, that's something that's going to be taken into account when each person acts as their own control.
Mr. Ferrer?
Yeah.
Let's say it snows, could that also mess with the experiment?
Yeah, but that's not going to change anything because, exposure to snow will be controlled by each person because each person will have the effects of the snow on an old boot and a new boot.
Right.
So,
it's just forcing you to go outside.
okay, does that kind of work here? B, could the design be double blinded? Yes. B, since the boots are indistinguishable, we can utilize a double blind experiment design. Each boot would need an ID number.
Wait, aren't subject volunteers?
Yeah. Each boot would have ID numbers, would need numbers, and the treatment of the boots would only be known by the researcher and not not the data collector. Or the subject. It doesn't say should it be double blind, it just says could it be double blind. Yeah, it could. Could you imagine that if it wasn't double, it wasn't at least single blinded? You as a subject, you have the new boot on the right foot, So you're gonna take your left foot and keep on dragging it in the water. I could see someone doing that.
Just,
Not even consciously, just kind of subconsciously. Just kind of.
I would think someone would just want to screw with it.
I probably want. Yeah, you probably subconsciously want to screw with it.
Like to screw with the experiment.
Okay, so that's pretty good. 2005B,
Oh yeah, totally.
FRQ3. Did I mention that these were actual questions from the AP test?
Figured.
I figured. Good thing to figure. Let's finish this then. In search of a new mosquito repellent that is safer than the ones that are currently in the market, scientists have developed a new compound that is rated as less toxic than the current compound. I almost read that compound as campground. Compound, thus making the repellent that contains this new compound safer for human use. Scientists also believe that the repellent containing the new compound will be more effective than the ones that ones that contain the current compound. To test the effectiveness of the new compound versus the current compound, scientists have randomly selected 100 people from a state using 100 bins with an equal number of mosquitoes in each bin available for the study. After the new compound is applied to a participant's forearm, the participant will insert his or her forearm into the bin for 1 minute, and the number of mosquito bites on the arm at the end of that time will be determined. That
This goes
is,
against all ethics of science right here.
but it's pretty awesome.
It's pretty awesome to see people in mosquitoes.
It's not $50, hells no.
This is the best time
That looks really bad.
whatever. Where's one where there's one area?
Okay. Up to 100 bins with an equal number of mosquitoes in each bin. So let's see. Suppose this compound is to be studied with a completely randomized design. Bye-bye. Describe a randomization process and an inference procedure for the study. Don't worry about the inference procedure. Let's talk about the randomization process. What would we do for a completely randomized design? Make two groups, okay. Randomly assign the 100 subjects into two groups. Okay. Using a, no, you don't have to get into that. Now what do we do with the two groups? Okay, what would group one do?
One group has tougher bond.
We'll apply the new compound
Okay.
on their forearm and insert their forearm into the bin as described. Group 2 will apply the old compound on their forearm and insert their forearm into a bin. The average number of mosquito bites for each group will be calculated and compared. Great, completely randomized. Lucky us. Lucky you, you get 1 minute of torture.
I don't know why you do that.
Okay, what if we want to use a match pair design? what would we have to match? What would be the greatest source of variability here?
People allergic to mosquitoes.
I feel like that. I feel like you would ask that before getting the person to do it.
Yeah, they
Otherwise,
wouldn't do it if you were.
Hmm.
That's something that I would do before I even selected people.
So what is the, let's get back to the question. We got to think about what is the greatest source of variability here?
Gender.
Gender?
I don't know if that's
No.
I think let's
What?
think that
blood sugar.
some skin
Yeah,
types
maybe
are
blood sugar.
prone, that could be possible.
So if we were going to match pairs, would we use a similar group approach? Or would we use a own control approach here? Could you use an own control approach?
I don't know if you.
Well, no, you could, because you know,
You can
one
do-
spray for one arm, one spray for another.
That's true, because like some people just have a natural tendency to be bitten more. You have to get some symptoms. Yeah.
Yeah, okay.
Poor people have to stick both
You
arms.
can do it all.
Okay, so we
as long as
can
you spray.
randomly assign the subjects into two groups. Group 1 will receive the new compound on their left arm, and the old compound on their right forearm. Group 2 will do the opposite.
Mm-hmm.
Oh, you know what?
What?
Maybe it doesn't even matter. Because they only have 100 bins, right? So maybe it's a matter of which one do you put in the bin first? The new compound or the old compound?
Wait, how many subjects do you have?
5 bin, you can put compound 1 in 1 bin and compound 2 in the other.
We only have 100 bins.
But they didn't say you couldn't reuse the bins.
Yeah.
Yes, reusing the same,
But that affects it, because what if the
Yeah.
It
mosquitoes?
also depends on how many mosquitoes are there.
and how often this is conducted.
Okay.
Depends on how hungry the mosquito is.
Yeah.
What if you're
So I
against
think,
mosquitoes?
wait, hold on. Group, the subjects,
And how hungry ones.
okay. We'll do the opposite.
I think this is the first
Okay.
chapter we have exactly no math. It's all explanation.
Okay, so group 1 is group 1 going to put the old one in or the new one in?
I'm thinking both.
We'll first insert the forearm with the new compound.
So if they're doing different
Hang on. New compound into the bin. Okay. For 1 minute. Then the forearm with the old compound into the bin for 1 minute.
What's the end in 1 day? Because mosquitoes might just go full.
Well, the mosquitoes are only going to be working for 2 minutes,
There's a lot of people.
where we have 100 bins. 1 bin per person,
No, it's 100 people.
and 100 bins. Up to 100 bins, yeah.
So
Okay, so group 2 will put the forearm with the old compound into the bin first, then the new compound. the difference in the number of mosquito bites between the two arms will be calculated. Okay, and then the average difference will be compared.
Arms at the same time, different performance. Well, kind of thing.
Yeah, you know, you could I mean, if you could put both arms in at the same time, then I imagine you would put both arms in at the same time.
But then, so wouldn't it affect if there's no separator? The
So it'd
arm-
be more prone to go to a different arm as a different.
Like you can see which arm you'll go for.
Not tie your left arm more than your right.
Will be calculated. Oxford comma. Okay, that's pretty good. I like that.
But if they put them in different times, does it really matter if they have different arms?
No, that's what I was thinking. It doesn't really matter which arm gets which.
They could say both arms pick, they just have one and one, doesn't really matter.
Yeah.
But then one group has to, and this one is first and then.
It doesn't. It doesn't really matter which one gets.
It's very hard to count all the mosquito bites.
Okay, so let's just say all part subjects will receive the new compound on the left form and the old compound on the right. Group 1 will put the forearm with the new compound first and then the old compound. Group 2 will put, maybe we'll put that other one, if possible. No, that's not good. That's fine. Okay. Yeah, and I can't wait to do all that reading.
Just don't give us a question like this, no reading. Yeah, it's just simple as that.
C, which of the designs, A or B, is better for the effect? Well, I think B would be better, right?
B would be better and more annoying.
B, the match pair. The matched pair design is better since the greatest source of variability is the subject's susceptibility to mosquito bites. I didn't expect that to be spelled correctly. The match pair design does a better job of minimizing the effects of this variability. That's good enough, I think.
So, how are the questions going to be on the test? Like,